We've talked about how to call almost every tool. The Spatial Analyst toolbox is one exception, which has been written differently. The Spatial Analyst toolbox does not follow the pattern toolname _ toolbox alias. Instead, you need to use arcpy.toolboxalias.toolname. For example, arcpy.sa, which stands for Spatial Analyst, .square root. So SA is the alias for the Spatial Analyst toolbox. This calls the square root tool on the raster we have here. Another item that you should be aware of, the spatial extension needs to be checked out if you're going to call a Spatial Analyst tool. So this statement, checkout extension spatial, would need to come before the tool call in a script. Another difference from other tools is that the Spatial Analyst tool returns a raster object. And if you want to save the raster file that it creates, you must call that save command explicitly. Otherwise, it creates a temporary in-memory raster which disappears when you have exited from your current session. So usually your script will contain a save command to save that output before the end of the script. This is done because raster computations can be very lengthy if you're writing the output every single time. You may want to do a series of analysis tools, call a series of analysis tools on a raster, or create input, output, and so forth until you finally get the output that you want to save. And so by saving that in memory, it makes it a lot faster because you don't have to go to read to the disk every time you want to perform the next operation. Instead, it keeps it in rapid access memory, which makes it faster to compute. But it also means that you have to keep track of that, and you should delete that object that it's created so that you don't end up with a situation where it's locked and you can't write over it for some reason. So there's a Python keyword called del, D-E-L, which stands for delete, and you simply call delete output rast, del output rast will do that. Here's an example, just putting everything together that we had on the previous slide of how it would show up in a script. We import Arcpy, set the workspace, set an output directory, and set override output to true. Then we set the input raster name and the output raster path. In this case, we're putting the output into the Scratch directory. We check out that Spatial Analyst extension, and then we can call the square root tool. So we're taking the square root tool will take the square root of the value in each of the cells and give you a raster that has that square root value in each cell. The next line does the save command that we talked about, that otherwise you'd just have this temporary raster object in memory and you wouldn't see anything appear in your directory when you finish the script. So we save that with output rast name that we set up here. So that means we will have a new raster that will be in C GIS540 Scratch named Getty square root. And finally, we delete the raster object. One more special case for calling tools. Well, the raster calculator is the one tool that's not available for calling in this way from Python. You can't say arcpy.sa.raster calculator. That will not be recognized. but you can do everything that a raster calculator does. You just need to use different techniques. There are two different approaches that you can use to, say, if you want to take the Getty grid raster, and multiply it by 5 and then subtract 2 from each of those outputs, then you can do that in 2 steps by calling the times tool and the minus tool. And this gives you the 2 things that you're going to multiply together. This shows the 2 things that you're going to subtract. Notice that we are taking that temporary raster object from the times call, and we're passing that in as input into the minus call. We don't need to save out rast1 before doing the minus. And that's where this is the kind of thing where you're saving time, because you're not writing it out to the hard disk before you perform the next operation and reading it in for the next operation. And then we would save the final output with the save command. The alternative is you can use the raster objects. This calls a function called raster, which returns a raster object. So we're creating a temporary in-memory raster object from our Getty rast, and then we can do Python arithmetic on it. 5 times rast object minus 2. So it looks more like an algebra equation that you would write. Then you would have a temporary output raster result, and you can write that to the disk. So these three lines would have the same result, except this one would create a raster with the name 2 at the end of the name. The ArcGIS Resource Spatial Analyst tool reference pages sometimes use a variation of the import statement in code samples, as in the following. From arcpy.sa import star. This statement creates a reference to the Spatial Analyst tool. It provides a shortcut so Spatial Analyst tools can be called without prepending, without putting arcpy.sa at the beginning of the tool call. So the statement arcpy.sa.square root can be replaced in the code with just square root. This is not universally accepted way of doing it, because in your code you may end up with some confusion. The statement int in rast, for example, looks very much like the statement int mynum. The difference between these two is that this is calling a spatial analyst tool, and this is casting a numerical value. But this could be some very confusing code to have together if instead you said arcpy.sa.int, the difference would be very obvious. Excuse me. So instead of using the statement that you find in the example at the beginning of the example, use import arcpy and then call arcpy.sa. and then the tool name. One thing that we haven't mentioned but is happening every time we call a tool is that it returns a result. The spatial analyst tools, we said that returns a raster object. That's explicit because we need to save it somewhere if we want to keep it. For other tools, it often returns the name of the tool, of the output itself, but it's storing that in a result object. So if you print that out, it'll say angle brace result c out.shape angle brace, and that's showing you that it's contained in a result object. Sometimes the result object will have a numerical value or a Boolean, and this is what would be passed on if you were using the tool in the middle of a model builder call. But sometimes that result object can contain multiple values. In all tool calls, the return value is an object, either a result object or a raster object in the case of the Spatial Analyst toolbox. Let's look a little bit more closely at that result object. The polygon numbers analysis tool returns a result object when we call it. If we say the type, it'll say arcpy.arcobjects.arcobjects.result, which is a long-winded way of saying I'm a result object. When we store this result object in a variable, we can then use the result properties and methods that are associated with any result object. This is from the table. We've listed only output count and get output in the table, but it has a number of other properties and methods. In the example down here, we have a result object in the variable pnResult. pnResult.output returns 1. pnResult.getOutput 0 returns ctemp pndbf. If we say print pnResult, we just get ctemp pndbf. But if you have more than one result, you can use these methods to get at them. If there's only one result, just use the print statement to print the results. In this example, the buffer tool just returns the full path of the output. If the result is multi-part, only one of the results is printed with a print statement. Average nearest neighbor statistics tool gives you multiple pieces of information in the result object. But if you print the result object, you get this number. So we need to use the output count and get output property and method to get to those the rest of those results. We use an assignment statement to store the result object, and then we can check the output count property. This one has 6 outputs. So we're talking about the property output count, which is listed under here. The get output method and index number can be used to get at other parts of the output. If we say get output 0, we get that 646 number. That's the nearest neighbor index. Get output 1 gives the z-score. Get output 2 gives the p-value. These are comments that have been added in here that'll just return these Unicode strings that could be converted to floats. In order to tell what each of the outputs is, you'd have to look at the help page to see that the second one is the z-score, the third one is the p-value, and what those things mean. This 2-part lecture on calling ArcGIS Toolbox tools with Arcpy has covered a number of topics. It introduced Arcpy, reviewed dot notation, the environment settings can be set with Arcpy, tools can be called with Arcpy, the tool help has a syntax and parameter table section with code examples later on the page. Linear units need to be specified as strings with a space between the numerical part and the measurement part. Tools that take Python expressions as input need a little bit of special care. If you're using a reference to another field, you can, for example, when you're setting the calculate field expression, you can use exclamation points around the field name to specify the field name. You can also use shape information to set the field. Some tools can take multi-value input objects. For example, if you're merging or intersecting or unioning, calling any of those tools, usually you'd have multiple values that you'd want to input into those. And those can be specified as Python lists, semicolon delimited strings, or using a value table object. The arcpy.sa import star is not condoned. The spatial analyst tools need to use double dots to be called. Use arcpy.sa the tool name. In fact, other tools can be called that way, but all of the help shows you the underscore technique. The raster calculator cannot be called directly with Arcpy. However, you can create any of the operations that you're doing there by using individual spatial analyst tools calls, or by creating raster objects and then making equations to calculate those values. Result objects can contain information that you may need within your code, and to get at that information, we'll talk about how to loop through the count that you get from the result object so that you could store each of those values in a list. The next lesson will be on user arguments, and then we'll talk about pseudocode. We didn't go over how to call custom tools, but that's available in section 6.8 in the textbook. That concludes today's lesson. Thank you.